So a new time skip has been found for any percent A-level paper speedruns in maths. It concerns questions like these. You must have a quadratic, it must be asking you for the equation of the tangent, and then you can just have any old point here. Now, of course, I'm pretty sure we all know the usual method for doing this question, but I won't go through that here. What we need to do is we need to complete the square on this thing here, but we need to do it in a very particular way. Not to make 2.5, because that's what 5 halves down to, but to shove this number in the complete the square. So we want this to be of the form x minus 1 squared. Right, so we want to make this into this. Now, of course, this, if you expand it out, gets you a minus 2x. So we just need to figure out what the rest of this is by adjusting. So minus 2x here means we needed a plus 7x to adjust for that. And then you'll get a plus 1 from here. Minus 5 there means you want a minus 6 left over. And then I think this will expand out and simplify to that. Now, the reason this is very quick is because we have the answer right in front of us. That is the answer. The equation of the tangent line is y equals 7x minus 6. Of course, we can do this with a different point here. So, for example, if we're using 2, then we complete the square here to make an x minus 2 all squared. And then that, of course, expands to minus 4x. So I'm going to need a plus 8x to adjust for that. And a plus 4, I'm going to need a minus 11, I think, to adjust for that. And the equation of the tangent is y equals 8x minus 11. This works if you've got a number in front here. It's a bit more fiddly. Essentially, you need to factorize out this 2. I did it just like this. I know that looks stupid. But complete the square on this to make it bx minus 3. And I think we need to do this because that expands to minus 6x, cancels there, plus 9 cancels there. Expand out this 2 and then collect together the terms, and I think you get this. And this is the equation of the tangent just there. And we have our answer. Good. So that's much quicker than actually doing the question properly. Very quickly, if you want to, we'll just prove that this works, I guess, every single time. So find the equation to this at the point x equals alpha. So what I'm claiming is if I use x minus alpha squared, and then come up with the adjustment. So I'm going to have a minus 2 alpha x when I expand that out. So to adjust, I'm going to need to have a plus brackets a plus 2 alpha x, because that expands to a minus 2 alpha x. So I'm going to cancel that out by using that. And then this expands to a plus alpha squared. So over here, I'm going to need b minus alpha squared. And my claim is that this is the equation of the tangent, right? That's my claim to this quadratic at that point. So okay, let's just very quickly prove it. And to prove it, we can just do it in the normal way. So we differentiate this. To get this, we substitute in the point alpha to get this. That's the gradient. So of course you can use y minus y1 equals mx minus x1 if you want, or you can just use y equals mx plus c and just now work out that y, the y coordinate when x is alpha is going to be this, because we just put alpha into there. And then we shove that into there, and we shove the x coordinate into there, and we get this. Expand out, some stuff cancels, and you end up with c being that. But of course that means that the equation is this, which I think is the claim that I had before. So the claim matches the result found by differentiation, and therefore we do have the right answer, and therefore this works. I'll leave it to you to prove the case when you have a quadratic of the form y equals ax squared plus bx plus c. I'll leave that to you to do now. But yeah, much quicker than doing the regular method, and very useful to use sometimes.